Yeah, I think I missed out something. Domain and range. Oh, this one cannot be brackets because I see that they are asking you for range as well. All these are topics that are in H2 Max. So, anyways, let me see. Maybe I should start with the tangent inverse. Or should I just go in order? Let me see. One more idea. Even functions. Even and odd functions. I think I talked about this before. Right? Even and odd functions, the definition.
Before.
Yeah, this one even is equivalent to what they're asking about the symmetrical about y-axis. Oh, that's even function. F of negative x equals f of x. Odd function is the other guy. F of negative x equals to -1 times f of x. Yeah. Okay, Ken, let's see. What questions are they asking you for? Maybe we start with this guy. State the following. It's the first picture you sent me, a gray color one. State the equations of all asymptotes of the following function. So what does that mean? First, you must understand, right. Sorry, one more idea. Inverse function f inverse of x. Okay, there's a lot of things to talk about. Basic idea is tangent inverse is just a reflection of the tangent x graph. Okay, so let's draw the tangent x graph. We draw it out. So it goes like this, and it repeats a few times, right? Forever, actually, not a few times. Forever. Let me just draw it first. So these are what we call the x equals pi over 2, then you plus a pi. So it's pi over 2 plus 1 times a pi. The next one will be x equals pi over 2 plus 2 times of pi, and so on and so forth. Plus 3 times of pi, plus 4 times of pi. Next one will be x equals pi over 2 minus 1 times of pi. Make a guess. What do you think is the next one?
Pi over 2 minus 2 times of pi.
And so on and so forth. So in general, the asymptotes, the equation of the asymptote. Asymptote means the graph will approach it but never actually touch it. Will be x equals to pi over 2 plus k times of pi, where k is an integer. Okay? Make sense? You can factor out the pi if you want to. You get half plus k. Okay, that is for tangent inverse. Now there is another idea that I never talked about, which is the idea of a domain of a function. So what is a domain? A domain is the allowed values of x. It actually, to be more technical, it's the set of allowed values of x. What's a set? A set is like this. It could be apple, banana. This is a set. But set, there's one key criteria, which is that repetitions are not considered. So apple appears 2 times, it's equivalent to apple, banana. These two sets are equal. Does it make sense?
Okay.
Okay, let's call this set A. Then maybe you have a blender. A blender is like a function. Okay, a blender is like a function. You put in fruits inside, then maybe you get fruit juice. Okay, let's draw a graph to represent this. Y-axis represents the fruit juice. What type of fruit juice? Many different types, if you can somehow rank them. Then the x-axis will be fruit. Here is apple. Here is banana. If you put in apple, you get a corresponding apple juice. You put in banana, you get a corresponding banana juice. Does it kind of make sense?
Okay.
Let's say I put in a third fruit, okay? Let's say I put in a third fruit. Let's say that I put in durian. Wow, put in durian. What a waste of durian. And then somehow you get this one. Is it possible for me to put in durian and I get back the same type? Sorry. How do I phrase this? Get back, say, the same type of fruit. No, that's a bad example. Sorry, don't put durian. Don't put durian. Let's say that I put in banana again. Let's say the first time I put in it's on Monday, but the second time I put in banana again on Tuesday. Is it possible for me to get a different type of fruit juice?
No.
No, right? If you put in the same input, you should get the same output. Or another simpler analogy is if you type in a calculator 2 plus 2 on a Monday, you get 4. And on a Tuesday, you type in 2 plus 2 again. Would you still get 4 or would it change?
You still get 4.
You'll still get 4, right? So the same input will give you the same output. Same input, let's write down our discovery. Same input gives you the same output. Okay, you can't have one input give you two or more outputs. That's bad, right? That would be bad because if you imagine our calculator, you key in 2 plus 2 on Monday, you get 4. 2 plus 2 on a Tuesday, then suddenly gives you 5. Then it's inconsistent, right? So in terms of a function, what this really means is, for example, if we have not fruit and fruit juice, but more like, let's say y squared equal to x. Here's how the graph looks of this relation, okay? This is a relation. A relation is just some kind of equation linking x to y. But is it a function? Is this y squared equal to x a function? The answer is a no. Why? Because it fails.
If you put x equal to like 4 or something, then you have to square root. Then you get two answers. You get plus 2 minus
x.
2.
Correct. One x value returns 2 possible y values. Then in that case, it's not a function. Or to represent it graphically, let's say you put in x equals to 9. Oh, then in that case, you will get, what you get as the answer? I believe you get positive 3 and negative 3. Yes, you will get that. So that means that there's 2 possible answers, which is failing what we call the vertical line test. Okay, a single x value returns you 2 different y values. This is undefined. Here's another example. Let's say we have let's say we have y equals to 1 over x minus 2. Here is x equals to 2. Then here is how the graph looks like this. Then I say that I define the domain here. Oops. Domain to be x more than 0. Okay, sorry. The graph should then be like this. Empty circle at x equals 0. This function is undefined. This this relation is not a function. Why? Does it pass the vertical line test? One x value gives you only one y value. 2 values. One. Does it fail the vertical line test?
No.
No, it doesn't fail. Then why? Why is it not a function? Why do I say it's not a function? It's because of this part here. This is the domain. So the domain is the allowed values of x. If you decide to define it to be x more than 0, it means you're saying all of the positive real numbers. All of the positive real numbers, which includes, the domain includes x equals to 2. But what happens when x equals to 2?
Math error.
Yes. X equal to 2 is in the domain. When you sub x equals to 2, y is undefined. Math error. So this brings up the second point about a function. A function depends on the domain. And a function must pass the vertical line test. Okay, the 2 key ideas. This is key idea number 1. Must pass the vertical line test. Okay, I should write it down at the side. A function, it must pass vertical line test. 1x returns 1y. And the second rule is it must be defined in all values of x in the domain. Defined on all x values in the domain. The domain will be provided by the question. Sometimes the question will be a bit more tricky. They will ask you to define the domain yourself. Okay. What is domain again? The allowed values of x. Set of. Okay, so usually if it's a correct question that's set properly, they won't give you this. They won't give you a value, they won't include an x value that is undefined. Okay, they will purposely exclude it. So maybe they will do something like, they will say something like, the domain is the set of x an element of all real numbers such that the x is more than 0, but x not equals to 2. Okay, I shouldn't put comma, I should be more precise. I should say n. And x not equal to 2. What does this mean? Let me break it down for you. This is read as x is in, sorry, let me be more precise. X is in the set of all real numbers such that it obeys the following rules. The dot means such that. Some textbooks will also use a vertical line, or they'll put a vertical line here instead of the dot. It obeys the following rules. What rules? Here, x is strictly more than 0, and x not equal to 2. Okay, I think this is clear enough. X not equals to 2. Does that make sense?
Mm-hmm.
So this domain contains different x values, all the possible x values, such that the x values are inside the real numbers. In the future, you may see x an element of this guy. What does it mean? The set of all natural numbers, which is really just the set of 1, 2, 3, 4. So no decimals. Okay, so it means that if you see x element of the funny symbol here, it looks like an E, but not really. Looks like a C with a line in the middle. It's read as element of or it's in. Then this guy will be the universal set, the set where the x belongs to. Okay, so here x can be a set of all real numbers, which is in set of all real numbers, means that it can be any positive number. Any real number can have decimals as well. Is that okay?
Okay.
Yeah. Then after that, such that something, you have certain restrictions on the x. It's not just all the possible real numbers. It's those that are positive and not equals to 2. Okay.
Mm-hmm.
Yeah, okay, good. So 2 key ideas about functions and domain. So here, in order to satisfy this rule about passing this vertical line test, you now need to talk about, and now I have to bring up the idea of the inverse function. So y equals f inverse of x. If fx equals tangent inverse, then sorry, let me start with, let's call this y equals g of x first. G of x equals to tangent of x. Then in this case, y equals to g inverse of x will be tangent inverse of x. Does it make sense? 10x becomes tangent inverse. Okay, so the idea of an inverse function is that you reflect it about the y equal to x line. If you can imagine, y equal x is over here. Can you see? Y equal x. Then you reflect it about this line. So that means that your inputs become your output and your output becomes your input. X becomes y and y becomes x. Does it make sense? It does the
Yeah.
opposite. Okay, so let's see how we can draw this graph. So let me just copy this. If I want to inverse, right, here's how it will look. I have to reflect it. So y equal to x looks something like this. Then if you reflect it, what you realize is that your vertical asymptotes here, x equals negative pi over 2 and x equals pi over 2. When you reflect, what happens? It turns into what?
Asymptote, but
what direction? But it becomes horizontal, right? So let me just change everything to red color to be consistent. Let me see, where's my red? Here. Then I want this x-axis and y-axis to be black. Then let's say I use orange color to draw the graph. So what happens now is you have y equals to pi over 2 and y equals to negative pi over 2. Then how would the graph look? You have to approach the now the current version of the asymptotes, which is horizontal. So it will look something like this, followed by this towards the asymptote. Can you see the orange graph? This is now y equals to tangent inverse of x. It is a reflection of the y equals to tangent x. Okay, make sense? Now, that's, you might be arguing, how come just now the tangent x graph only got multiple curves, right? I only copied one of them, right? You see, I only copied the first curve in the middle. Or maybe I should use black to be consistent. Let me do that. Oops. Right. Not so nice. We try make it look nice. So what you may be arguing, how come just now we only had one curve here? I mean, how come I only draw one curve here when there are actually multiple curves? What happens if I include another curve and I try to reflect it? Here's what will happen. This curve here, after I reflect it, it will end up being, let me see if I have enough space. No, I don't. Let me copy this to a new page. What will happen is that I will now need to have another copy of this graph. Okay, let me just copy it down. Copy it over like this. You see what I'm doing? Then you have another asymptote, but it's not pi over 2, it's pi over 2 plus 1 times of pi. Right? This, okay, maybe I should highlight. This original graph is the green one. It becomes reflected into this green one at the bottom. This purple one will get reflected into this orange one at the top. But there's a problem if you reflect both of them, the green and the purple. This guy here, does it pass vertical line test?
No, sub in one value of x, you get two values of y.
Correct. So it fails, right? So that's why we have this idea known as the principal domain of trigo functions. We have to restrict the domain, the allowed values of x, so that the inverse function, like the graph I'm drawing right now is the tangent inverse x function, will still be a function. Be a function. How do you be a function? You must satisfy the two rules. What are two rules? You must pass vertical line test. That's your rule number 1. Rule number 1. Rule number 2. Pass vertical line test. One single x corresponds to one single y. And the rule number 2 is all defined on all values of x. Defined on all values in the domain. Okay, so here, because it fails the vertical line test, you don't want that. So what we do is we say, no, I don't want this purple guy. I don't want this purple guy. Let me get rid of it. Remove. Okay, then that means that you will only have the original tangent x graph to be restricted to negative pi over 2 to pi over 2. Can? Does it make sense? Okay. That's the principal domain. So let me just tell you what are the principal domains are. For tangent x, it will be negative pi over 2 less than x less than pi over 2. You cannot include pi over 2, if not, it will be undefined. Well, maybe I shouldn't have used pink. Let me use a different color, black. Looks nicer. Let me zoom in. For sine x, it will be, what is it? Let me recall this. I need a full curve. So it's a 0 to, if I am not mistaken, I might be wrong about this. Let me think a bit. Sorry, no, it's not 0. It's negative pi over 2 to pi over 2. So which part of sine x is it? Sine x looks like this, followed by another version. You only want to restrict it to this part here. Then for cosine x, it will be 0 less than x less than pi. So cosine looks like this and this. You only want to look at this part here. Okay?
Yeah.
Can? So there is also another hidden rule here. What's so special now that I've restricted it? It doesn't just pass the vertical line test. It also passes something known as the horizontal line test. Why? What is horizontal line test? When you draw a single horizontal line, it represents one possible y value. Then we are looking for how many corresponding x values there are. If you focus only on the pink color part, what you realize is for one possible horizontal line y equals something, it only intersects the graph one time. So there's only one corresponding x. So it's the other way around. Just now, vertical line test is draw a vertical line for one x value, you only get one single y. Now it's the other way around. One single y, you only get one single x. Does it make sense?
Yeah.
Okay, so what that really means is in order for f inverse x function, the inverse function, to exist, you will need the original fx to pass horizontal line test. If the fx passes horizontal line test, it implies that f inverse x will pass the vertical line test, so that the function f inverse is defined. Does that make sense to you?
Mm-hmm.
Like for example, okay. So let's go back to tangent inverse x. If I chop off all the other parts, I don't want the left half, I don't want the right half. I only want one single copy in the middle. If I draw a horizontal line, how many times does it intersect the green color graph? One. But if I didn't chop off all of the copies of this graph and I draw a horizontal line, how many times does it cut in this specific case?
Like infinity.
Infinity times, right? If it goes on forever. So that means that we cannot have the original tangent x graph with all the copies. We can only have this one, the one in the middle. Okay, so to answer the question that you are asking, that your question asks you, the prerequisite question, what do you even call these questions? Looks like spam. So state the equations of all asymptotes of the following function fx equals tangent inverse x. The asymptotes is just x equals pi over, wait, what? X equals to pi over 2 and x equals to pi over 2 minus pi. If you simplify this, it becomes negative pi over 2 within the principal domain. Okay? Okay, good. Sorry, no, I'm not answering the question. This is for tangent x. This is our tangent x. Sorry, that wasn't the answer. No. The question is asking, state the equation of all asymptotes of the following function, fx equals to tangent inverse of x. So I shouldn't be looking at this guy. I should be looking at that guy, this guy. So what's my asymptotes? It's already on the graph.
Y equals to pi over 2. Y equals to negative pi over 2.
Yes, correct. Okay, that's it. Pi over 2, negative pi over 2. Okay, good. Let me see another possible question you probably cannot answer. I'll just answer these then. Secant 2 secant x minus 2. Okay. Next one. You have fx equals to 2 secant x minus 2. And you want to graph this? Okay, part 1 is to draw a sketch of the graph. Part 2 is to express the range. Okay, let's take a look. So first thing is rewrite as something you know. This is 2 over cosine x, right? This is a topic called graphical transformations. So what we want to do is to start with something that we know. Let's say we start with y equals cosine x. How does it look? Down, down, up, up, right? Let's just repeat this a few times. So with the power of an iPad, I can just copy and paste it a few times. Okay, that's good. Then now there is a topic in H2 Max, which is about graphing the reciprocal function. So if you start with f of x, y equals f of x, how does the y equals 1 over f of x graph look like? Let's think about it. Let me make a few more copies so it looks nicer. Maybe I'll just draw my x-axis like this. Okay, let's think about it. So if this is f of x, let me change to say blue color. How let's just think about it. This one is 0, 1, correct? Cosine x. Then what happens if I try to draw my 1 over f of x? That means that I will pass through x equals 0 and y equals to 1 over 1, right? X equals 0, fx will be f of 0, which happens to be a 1. If you let f of x equals to cosine x, right? Then how about when x equals 0, what is 1 over f of x? It's 1 over f of 0, which is 1 over 1. You take the reciprocal, 1 over. It's just 1, right? Then as I increase the value, okay, and if you take a look at this function, as the x increases up to before this point pi over 2, when x increases, the y is decreasing. In other words, the f of x is decreasing. Then what happens to your f of 1 over f of x?
Increasing.
Sorry, decreasing. F of x is decreasing. Sorry, this part here. Then what happens to your 1 over f of x?
Increasing.
It does the opposite, increasing, right? But eventually you'll get very, very close to 0. Like let's say it goes to 0 0.1, 0 0.01, 0 0.01. What happens when you take 1 over 0 0.1 versus 1 over 0 0.01 versus 1 over 0 0.001? This becomes 10, this becomes 100, this becomes 1000. What's happening? It's increasing, right? But it will eventually go all the way to what value? The y value can go as small as you want, right? This could be 0.1, this could be 0.01, this could be 0.001. It can get closer and closer towards 0. But 0.0000001, if you take 1 over, what does it become?
Like a really, really, really big number.
Yeah, exactly, right? 1 over 1000, 1 over 100,000. So that means, 1 over 0.000 something. It will become a very big number, which means that it will go towards positive infinity. Does that make sense?
Okay.
It just keeps getting bigger and bigger. So what this means is, the next observation we make is, if fx equals to 0, what happens to my f of x? It will go towards infinity. It will have a asymptote. Vertical. So what this means is the graph will now look like this. there will be a this is an asymptote. This is pi over 2 because cosine x graph, you know, is pi over 2 comma 0. It cuts through this point. But the blue color, what I'm drawing now, is representing the secant x graph. Okay, 1 over of cosine x. I'm trying to draw 1 over of cosine x, which is secant x. That means that this part of the graph will go towards positive infinity. Then what do you think happens to the left half here? You see, on the left half, what do you think will happen when the y value drops closer and closer towards 0? What happens to your 1 over?
So approaching infinity.
Right. So that means, how do you think the graph will look? Must be like this, right? We can make it look nicer. It will look like this. That's a secant x graph. But that's when fx is positive, then it stays positive. So let me just write this down. Fx is more than 0, 1 over f of x will also be more than 0. But what happens when it's less than 0? Positive 1 divided by negative will give you
Less than 0.
Less than 0. So it will be below the graph. Make a good guess. What do you think will happen over at this point here? This point here is pi comma negative 1. Cosine of pi is negative 1. How does the secant x graph? There's definitely a vertical asymptote, right? When fx equal to 0, cosine x equals 0, then 1 over of fx will just be going towards infinity, positive or negative. Oh, sorry, let me qualify this. Plus or minus depends on fx. Wow, this is too big. Depends on the sign SIGN of f of x. Positive sign, then it will go to positive infinity, negative will go to negative infinity. Go towards positive infinity, go towards negative infinity. Okay, I shouldn't write that down. That's not very accurate. Yeah, I think this is clear enough. Depends on sign of fx. If this fella here is equal to 0, but it's approaching from a positive values, then it will go towards positive infinity. If it's approaching from negative values, then this will be negative infinity. So let's think about it for this part here. First thing is, this cosine x graph is negative, right? It's below the x-axis.
Yeah.
So the fx value is negative. What about 1 over fx? It will also be
also negative.
So definitely you have to appear below x-axis. Then if this point here is pi comma 1, right? In other words, x equals to pi, f of pi, which is cosine of pi, equals to 1. Sorry, negative 1. Then what happens to your 1 over of f pi? 1 over fx when x equal to pi? It will be 1 over cosine. 1 over negative 1, which is still negative 1. So it will definitely pass through the same point. But let's think about it. When this value is getting closer and closer towards 0, what happens to our f of x? It will approach
infinity.
Yes, but here, because it's negative, right? You see, think of it like this. This different points here. Maybe I should label the points a bit more precisely. For example, this could be, I don't know, let me think. Pi is around 3.14. This guy is 3 pi over 2, which is, let me get a calculator out. Calculator, come out. 1.5 times of pi, which is around 4.7. Let's say that we plot a few points, then this guy here is, I don't know, 3.3. Then what's my corresponding cosine of 3.3? I get around negative 0.98. Let's say I plot another point. I hope it's clear enough. Can you see the 3.3? let's say I go 3.8. Sorry, maybe I go a bit faster. This one 4.7, right? Let's say I go to 4.5 already. Then what's cosine 4.5? Type in a calculator, I do it for you, I get negative 0.21. Okay. Then finally, let's say I just go to 4.700. Let me see, what's the exact value again? It was 4.712. So let's say I go for 4.7122. Then what's cosine of 4.712?
Like
Negative 0.000188. Right?
okay.
All these values, negative 0.98, negative 0.21, negative 0.000188, they are just the fx values. So what happens to 1 over fx? It will be 1 over negative 0.98, 1 over negative 0.21, 1 over negative 0.000188. What does that equal to? Let's see. Type in the calculator. 1 divided by negative 0.98, negative 1.0204. How about 1 over negative 0.21? You get negative 4.7619. How about 1 divided by negative 0.000188? You end up with something like negative 5319, 5,000. What's the pattern? What's the pattern?
The number gets smaller and
Gets
smaller.
smaller towards what do you think? From 1s to 4 to
What's
5,000.
negative infinity?
So the only way that you can draw the graph must be this way, downwards. Make sense?
Okay.
So when it's approaching a 0, you will go towards infinity. But which infinity? Positive infinity is all the way above, negative infinity is all the way down. Here, it's already below x-axis, which is negative, so it will go towards negative infinity, go down. Make a guess, what do you think happens to the left half here? Will it go up or go down?
Symmetrical.
Symmetrical, right? It's going to go down, yes. Like this. Okay, then you can repeat for all the other points. It will just look like this, like this, like this, like this. Okay, my graph is not so nice. Let me just show you on decimals. The easiest way, just watch on decimals. Let me show you. Y equals secant of x. Ta-dang. Y equals cosine of x. Can you see? So cosine x is the blue one. Then you realize that at each of the points where it's a turning point, it happens to touch it. But the secant x graph, because it's 1 over, there's the vertical asymptotes. Let's draw a few of them. Let's say x equals to pi over 2. Then the secant x will approach it. Okay. Then there's another one, x equals pi over 2 plus 1 pi. 1 pi. The other guy, this one. Plus 2 pi, and then it goes all the way to the right. Minus 1 pi is on the left. Minus 2 pi, a bit more to the left. Minus 3 pi, a bit more to the left. Okay. Then now we have to answer the question, what is the range? What is the range? Range means what? Range means the allowed values of. Domain is allowed values of x. So what do you think is domain is allowed values of x. So what do you think is range? Must be allowed values of y. Yes. So let's take a look at the graph. Where is my screen? Give me a second to load the screen. So what's the allowed values of y? Look at the blue color graph. They all.
Is it not in like infinity, negative infinity?
Yes, it will include infinity, but there is a certain value, a certain boundary that it never exceeds. Look carefully at the graph.
It doesn't go in between like 1 and negative 1.
Yes. So now you need to learn how to use set notation to describe these values. It goes to, so it's essentially going to all possible values except for -1 and +1. Can understand the idea?
Yes. Okay,
If on a number line, here's how it looks. Here is -1, here is +1. A lot of values are all the way to the left, all the way to the right, but not the values in between. Can it be exactly equal to -1 and +1? Can it be exactly equal?
yeah. Wait,
Can now? Yes, yes, it's touching one. It's
it's a point.
touching the point. Yeah. So that means you should shade in the circle. So now you must translate this diagram, the inequality, into a set notation. Here's how you do it. You will say that the range, let's denote, okay, there's no a particular letter to denote it. Usually we pick a letter to denote it. Let's say I randomly pick letter B, capital letter, to represent a set. Then I will say y an element of all real numbers such that it obeys a certain rule. What rule? They are all the y values that are less than or equal to -1, more than equal to 1. So let me write this down. Y less than equals to -1, y more than equals to 1. However, you need to understand that there's a bit of logic involved here. You need a logical operator. It's either and or. And or use or. Which is the correct one? What do you think?
Or wait, and both. Wait, yeah, both and.
Wrong. It's or. N means you have a y value that can be both less than -1, that satisfies both rules at the same time. The first rule is less than equal to -1.
Okay.
Second rule is more than 1. Can you be both at the same time?
No, you cannot.
But you still want both. Then that means you must use an or. Does it make sense? Yeah. Hope it makes sense.
Okay.
Can N means you satisfy both at the same time, or all of the conditions at the same time. Yeah. So. Okay, good. Then, by the way, just to give you some extra ideas, or here, you just need at least one of the statements to be true. Statements, the true statements here are y less than equal to -1, y more than equal to 1. At least one of these are true, then the whole thing is true. Then the whole thing is true. The whole statement being y less than equals to -1 or y more than equals to 1. And the whole statement, maybe I should highlight this. Whole statement is referring to the whole thing here. Will be true. It's true. Okay, that's a logical or. If you learn programming coding, then you'll know this. Okay, that's how you describe the range. Let's see, another question. What's another question? You probably don't know. Determine algebraically if fx equals to that guy. Let me write this down. Copy the question first. Determine if fx equals to x squared over 2 plus cosine of x is symmetrical about the y-axis. This is really just code word for saying fx is an even function, which by definition means f of -x equals to f of x. Okay? It's a definition. You should probably memorize this since they tell you need to know this. Even means f -x equals f of x. So if you recall, like, what are some examples of even functions? Cosine x is an even function. It's symmetrical about the y-axis. What's another simple function you know of that's symmetrical about x-axis? About the y-axis. Can you name me another example?
Sine.
Sine.
Wait, no, it's not.
No, this is an
It's
odd
not.
function.
Or x squared.
X squared, yes, that works. Happy face. Y equals x squared. Okay, so let's just deal with this question. Let's see how we can show that this is an even function. So what you need to do is sub in x with negative x. So what you need to understand here is that everywhere where there was a, hold on a second. Let me see. Everywhere where there was x, you must replace with a negative x. X. Now I change into negative x. Okay. So negative x on top, and all divided by 2 plus cosine of negative x below. Okay?
Okay.
Okay, good. Then what's cosine negative x?
Cosine of negative x.
Yes.
I thought you cannot bring it out. Wait, no, it's
Wait, hold on a second. Did I copy wrongly? Oh, sorry. This is an x square. I never copied. Sorry, I hide. I didn't see a square. Sorry. Let me write this down. There's a square there. Sorry, I forgot. Bracket power 2. Okay. Yes, you cannot take out. So that means it simplifies down into cosine just like x. And the other guy, negative x bracket square becomes negative 1 square x square, which is x square. Is that okay?
wait. Cosine minus x equals to cosine x.
Yes.
Okay.
Yes. And you see,
Okay.
just pick a here. This is negative a. They will map to the same y value. y1. Okay, maybe I call this x1 and negative x1. And I get the same y1.
What's the other thing besides the cannot tap out the negative sign for like I know you say like, oh, remember that cosine is the weird one or like the bad one or like
sine of negative x, cosine of negative x, tangent of negative x.
Negative sine x, then cosine x, then negative tangent x.
Exactly.
What's the other one? Is that not like another one like where you say like, oh, cosine is different?
Sine of a plus minus b, cosine of a plus minus b. This is sine a cos b, cos a sine b.
Okay.
The other one is cos a cos b, sine a sine b. Yes.
Okay.
And I think you remember by now.
Yeah.
The top one is plus minus, the bottom one is minus plus. Misbehaving. Misbehave. You'll see this everywhere. Every time there's a cosine, it just misbehaves. It's just different from everybody else because it's an even function. Sine and cosine is but sine and tangent are odd functions. Odd. That fella is even. Okay. Even functions behave a little bit funny. Okay, so anyways, what we realize is this is now equal fx, and therefore fx is even.
Okay.
Good. Let's see another one. Another one you probably don't know. Find all solutions to the equation sine 2x minus cos x equals 0. All solutions. This okay, actually you can solve this. Just need to expand this sine 2x as 2 sine x cos x, right? Then you factor out. Common factor cosine x. Oops. I meant to write cosine x bracket, and multiply 2 sine x minus 1. Okay so far? Factor, I mean, each of the factor must be then equal to 0, because something times something equals 0, each of the factor is equal to 0. Solve, you get sine x equals to half. Then always please find the alpha first. Alpha means sine inverse of, ignore the sign in front, just take the number half. I don't know what sine inverse of half. Let's see. Do I know the sine inverse of half? Let me think. Yes, I do. It's pi over 6. Reason, triangle. You chop it. This is what do you call it? 30, 60, 90. 2, 1, and square root 3. Okay. And half means sine of 30 degrees gives you the half. So sine inverse of half is 30 degrees. 30 degrees is actually just pi over 6. radians. Okay, then from there, because this is positive sign, then you have to use ASTC. Positive which quadrants? Top 2. So therefore, x is the first quadrant, pi over 6, or the second quadrant, 180 degrees, which is pi minus pi over 6. Simplifying, you get 5 pi over 6. Okay, so now let's think about it in terms of a graph. What does sine x equal to half mean? It means that you have a y1 equals to sine x, you have a y2 equals to half, and you're drawing the two graphs simultaneously. And at the point of intersections, you look at the x coordinates, that will be your solution. So what do I mean? I mean, you draw sine x, repeat a few times. Repeat a few times. Let me just get rid of this. And another copy, let's say like this. Okay, this is sine x graph. Is that okay? Y equals sine x. Then where is y equal to half? It's somewhere over here. Something like this, right? Then that's my y2 and that's a y1. So how many intersections do you see? Many, right? Infinitely many. Correct? It just keeps going. The y-axis is here. So the two solutions that you just found are pi over 6 and 5 pi over 6. It's actually here and here. This is pi over 6. That's 5 pi over 6. The horizontal distance over here in blue and blue there, that's pi over 6. That's also pi over 6. Pi is over here. Pi minus away pi over 6 brings you back to 5 pi over 6. Does that make sense?
Okay.
That's why we have to subtract pi over 6. But then what you realize is that how about all the other solutions in all the other point of intersections? We also need their corresponding x coordinate. How do we capture all of them at the same time? That's why we need to see a pattern. Do you see the first? Okay, wait, let me box it up nicely. Something like this. Do you see this first box? Let me change the color into something else. Let's say, I don't know, orange. Let me copy this, blue. Okay, do you see the second box here? Oh, sorry, no, wrong. My box wrong already. I need to make it a bit bigger. I meant to cover up to 2 pi. Okay, maybe a bit more accurately. This. And then I, duplicate it. I get a different color. Can you see that I have a second box over here? This second box.
Yeah.
It also has two solutions, but what's the pattern? From the first solution to the next one, you plus 2 pi. Then the second one to the second one, you also plus 2 pi. Right? So that just means that this guy here is pi over 6 plus 1 times of 2 pi. Can you see that it's 2 pi? Because one full cycle is 2 pi, then plus a bit more. Then the other guy will be not pi over 6, 5 pi over 6 plus 2 times of 2 pi, right? Sorry, not 2 times. What am I saying? 1 times of 2 pi. How about the next box? Copy and paste the next box. What would it be for this solution?
Pi over 6 plus 2 times 2 pi. Then the other one is 5 pi over 6 plus 2 times 2 pi.
Yeah, and so on and so forth. It will just be plus 1 times 2 pi, plus 2 times 2 pi, plus 3 times 2 pi, plus 4 times 2 pi, all the way. But if you go in a positive direction, it's plus 1 times 2 pi, plus 2 times 2 pi, plus 3 times 2 pi. But sorry, let me write down first before I forget. 2 times 2 pi. How about if you go in the negative direction?
Minus.
Instead of plus, minus. How do you capture everything in one shot?
Pi over 6 plus k2 pi.
Plus 1, can be plus 2, can be plus 3, all the way. But it could be 0, it could be -1, it could be -2, it could be all the way. So how do you capture all the cases? It's k times of 2 pi, where k is an element of the set of all integers. The z there, the funny looking z there means the set of all integers. 1, 2, 3, 4, 5, 6, 0, -1, -2. This bunch of numbers here. Does it make sense? You write it like this, z and then extra line and then z. Some people write it as just a z then extra line. It's called blackboard board if you're interested. Not important. Blackboard board notation. But anyways, yeah, so that's the general solution. Pi over 6 plus k times of 2 pi. Does it make sense?
Okay.
That's for one of them, but of course you also got the 5 pi over 6, right? So you need to have 5 pi over 6. Again, it's plus 1 times 2 pi, plus 2 times 2 pi, plus 3 times 2 pi. But it could be 0 times 2 pi, which is the original solution. Or it could be negative 1 times 2 pi to go in the left one time, negative 2 times 2 pi to go 2 times to the left, and so on. So again, you have, in general, k times of 2 pi. Does that make sense so far? Some students struggle to understand the general solution now. That's why it is not taught in the AMAX syllabus. You need to know for A levels. Is it okay?
Yeah.
Cannot? Okay, good. But that's not enough because that's only the right half. We only dealt with the right half, still got the left half. So cosine x equals 0. Let's just draw a graph because it's equal to 0. Draw cosine x, draw cosine x. Where is y equal to 0? It's over here. This is y equal to 0. Where's the intersections? Here and here, right? So this is pi, this is plus pi. So 2 pi. If you continue drawing,
K
let's
pi.
draw another. Yes, very good. You got it. So this one is 3 pi, then this one is negative 1 pi, this one is negative 2 pi. You get the pattern. So in general, it's just k times of pi. K times of pi. K can be 0, 1, 2, all the way, negative 1, negative 2, all the way. Okay? Where k is an element of all positive integers. So how do you represent all of the solutions nicely? What you do is you collect all of them together. K pi, k an element of integer. Pi over 6 plus k times 2 pi, k an element of all integers. And then 5 over 6 pi plus k times of 2 pi, k an element of all integers. You just say x equals to all three possibilities. Let me erase the arrow. And then you put down comma k an element of z, comma k an element of z, comma k an element of z. But that's a bit repetitive, right? You see the comma k over element of z. So repetitive. How about a more efficient way? Just write down at the bottom one time where k an element of z. If you want, you can also spell it out in full English where k is any integer. Okay? This is called the general solution of a trigo equation. I did not teach you this before. It's just a presentation, right? You already know this. Plus 2 pi, plus 2 pi. Yeah. Just that you need to introduce the k, which is confusing for many people. Only in A level, then you need to know. Okay, move on. Next. Let's see. Another question you probably don't know how to solve. Let's see. Simplify, know how to solve this. Exact value of tangent 2 theta. I know how to do that. Period and amplitude. Confirm you know how to do that. Find trig identities, pi over 3 plus pi over 4. Yeah, you know how to do that. Graphing, right? This one. Fx equals to piecewise function. First piece at the top is modulus x plus 3 if x satisfies the condition that it's less than equals negative 1. Second piece, x squared plus 1 if x satisfies the condition strictly more than negative 1. So what this means is that you are going to draw the x and y axis. You plot in x equals to negative 1. Then there will be a this is not an asymptote. It's just I'm just drawing this to help me. Okay, maybe I don't use a pen ink. I'll use a highlighter to remind myself that there's a left half and a right half. Who do you think is represented by the left half? What are you going to draw on the left half? Must be this guy. Less than equal negative 1. How about the x squared plus 1?
More than.
So you're the right half. Yes. Okay, so now let's see how to draw this. Modulus x plus 3. Here is the procedure to drawing modulus graph. Just draw a quick sketch. Y equals to x plus 3 first. Okay. Our goal is y equals mod x plus 3. So let's just draw y equals x plus 3 first. 1 x plus 3, positive gradient like this. But positive 3 as the y-intercept, right? So move up a bit. There's a 3. Oops. Is it clear? Mod x plus 3, okay. Now you want modulus x plus 3. Modulus means that you want all of the y values to be positive, which simply means that the parts which are below the x-axis, you have to reflect it on top. Reflect it on top. So what you end up with is whoop, whoop, a V shape. Victory. Here the intersection is what is it? Sub in y equals 0. 0 equals x plus 3. Solving, I get x equals -3. Is that okay? By the way, y equals modulus x plus 3. Do you notice that this right half here, is really just y equals x plus 3. But you restrict the domain to x more than -3.
Okay.
Then the left half here is just the negative version, because you see when you reflect it above the x-axis, you're just multiplying everything by -1. So this right half, if I can just choose a highlight, I will get y equals to negative bracket x plus 3 for x less than -3. Okay. When x equals to -3 itself, in both equations, it will just be equal to 0. So it doesn't matter, just put an equal sign on one of them. Okay? Yeah. So how do you present this blue color and yellow color in neat notation? Here's how you do it. Y equals to modulus x plus 3 is equals to the piecewise function. This is the open half curly brace. Set notation uses open curly brace and close curly brace. You just use the left half. Okay. Then you have one row here, comma the domain. Row here, comma there's these blank spaces. This is the rule. This part is the domain. The x. So what's the rule here? It's the yellow piece x plus 3. What's the domain? X more than equals -3. What's the other rule? Negative bracket x plus 3. What's the domain? X less than -3. Does it make sense? Okay, good. That's how you draw that's how you write down a piecewise function. Piece by piece. The yellow piece and the blue piece. And okay. Can? Good. So now that you have the y equals modulus x plus 3 graph, you have to transfer it back into this picture here. You want the modulus x plus 3 for x less than equal -1. So where's -1 here in this graph? Where's x equal -1? Can you draw a vertical line to represent x equal -1 here?
It's like here.
Good. Chop. Okay, so we're gonna take the left half of this graph and we're gonna transfer it to the main diagram. So where's my -3? -3 is over here. So it will be a V shape like this. Oops, the y-axis is not tall enough. Let me just move this down, extend this a bit. Like this. But you must chop it off at x equal -1. So we're just gonna scribble this away. Can erase it neatly. What is this point here? What's the coordinates? X equals to -1, y equals to modulus -1 plus 3. Right? How do you read this? Oh, by the way, when x equals to -1, which piece do you use? Which rule is
When
satisfied?
x equal to -1 is this one.
Yes. Why? Because
This.
less than or equal. You obey this blue color rule. That's why you use you obey the domain over here. So you use its corresponding rule to of that domain. Does it make sense?
Yeah.
Okay. How about if I have x equals to -5? Which one do I use? Which function do I use? -5. X equal -5. Which rule do you obey? Blue or green? Which one? When x equals -5, for example.
Wait. This.
Yes,
This.
less than is -5 less than or equal to -1? Yes. Yeah, so you use this. How about if x is +10? Which rule do you satisfy? Which domain? Sorry, I keep saying rule. Sorry, this is the rule. That's the domain. Which domain do you satisfy? X equal to 10.
This.
Right half. Then therefore, if you want to find the corresponding y coordinate, sub x equal to 10 into the green guy. Very good. And 10 squared plus 1. Okay. Well, anyways, we only need -1, so it's modulus -1 plus 3, which is modulus of +2, which is just a 2. -1, 2. Can? So we just draw 2. Can I just erase this to make it look nicer? Just gonna erase away this part. Okay, can? Can good. That is the left half. How about the right half? X squared plus 1. So we have to quickly draw the graph. So y equal to x squared looks like this now. Happy face. But y equals to x squared plus 1. This is graphical transformation. You have to translate it vertically upwards by 1 unit. Should I just give a crash course on graphical transformation right now?
That's up to you. I'm okay with anything.
Let's do it. Okay. Before I even begin this question, graphical transformation, there's only 4 things you need to know for the basics. Y equals to f of x. You can transform it, into y equals to d plus c times f of bx plus a. Okay. The ones that are affecting the insides of this f of something, these are known as the horizontal transformations. The D and the C is known as the vertical transformations. I'm just gonna use the short form. So example, let's start with y equal to x squared. Here's how it looks. Y equals to x squared. Let me just draw it in. Then what happens if I have y? Let's call it f of x. What happens if I ask you to draw for me, sketch the following, sketch y equals to f of x plus 1. How would the graph look? Here's how you draw it. Here's how you do it. If you plot a few points, you quickly realize that plus 1 will essentially result in the graph moving leftwards by 1 unit. Okay. Why? I just plot a few points. Let's say you put -1, x values to be -1, 0, and 1. Then the y will be -1 square, which is 1, 0 square is 0, 1 square 1. Then if x equals to -1, 0, and 1, what's the corresponding x plus 1?
0.
0, 1, then 2, right? Good. Then in this case, what's f of x plus 1? What's f of x plus 1? X plus 1 is 0, 1, and 2 already, right? So f of 0, f of 1, and f of 2. Does it make sense?
Okay.
What's f? What's f? F is this guy, x squared. Fx equals x squared. So f of 0 will be 0 squared, which is 0. F of 1 and f of 2. What are they equal to? 1 square, 1. 2 square, 4. Do you understand the function notation?
Okay.
Can So 0, 1, 4. So what you realize is maybe I put in one more point. Here it's 2, then the corresponding is 2 square 4. What you realize is that when x is -1, 0, and 1, you end up with the same y value 0, 1, 4 as these guys here. But the x values are shifted 1 position to the left. You bring it down over here so you can have an easy comparison. When the 0, 1, and the 4 is the same, the -1, the 0 got shifted to -1. The 1 got shifted to 0. The 2 got shifted to 1. You subtract 1. The x values we subtract 1. Decrease by 1. Okay, to get the same y coordinates, your x values become smaller by 1 unit when it's a +1. That's why the graph moves towards the left by 1 unit. X becomes smaller by 1 unit, move left by 1 unit. Does that make sense?
Yeah.
Okay, yeah, so that's a general rule. Plus, then you move left. Minus, you move right. Okay, but this plus and minus is inside the f of x. So it's a transformation on the bx, on the x in f of x. Okay, so now let's try something else when the +1 is outside. Let's try restart. So now this time it's y equal x squared fx, but then now I want you to sketch y equals to fx, but plus 1. As compared to the previous one, this is not the same as f of x plus 1. Okay, previously it was f of x plus 1. You just shift it towards the left by 1 unit. This time it's fx, then plus 1. What happens? What changes? The y value changes, right? If x is -1, 0, 1, y is 1, 0, and 1. -1 square, 0 square, and 1 square. But what happens if I now have the same x values? What happens to my y values? Ends up being 1, 0, and 1, but you have to
Plus 1.
plus 1, plus 1, plus 1, which gives you 2, 1, 2. What does that essentially mean? It just means that your graph moves upward by 1 unit. Y transformation is easier because it's just moving up. It's like going up an elevator. Plus, you move up. Minus, you move left. Down. What am I saying? Minus, you move down. Okay?
Okay.
Okay, that's plus and minus, but there are 4 operations like plus, minus, times, and divide. We haven't discussed times and divide yet. Let's discuss it now. So let's try another example. Oh, need more space. Let's say I have y, same thing, y equal x squared times f of x. This time I want you to draw y equals to f of 7x. What does that mean? What's 7x? Oh, sorry, I didn't write down the simplified version. It means 7x bracket square, which is, you know why it's 7x bracket square, right?
Okay. Yeah.
Yellow is yellow, the blue is now the blue,
Yeah.
with an invisible pair of brackets. Okay, good. Then you end up with 49x squared. So how does it look? It simply means that if you plot a few points, it becomes sharper. Okay, this is called scale parallel to the y-axis by a scale factor of, in this case, 7. Okay, if you times a number that is a, you just say scale by a scale factor of a. Scale parallel to the y-axis by a scale factor of a. Okay, that's multiplication. Division, what if you have, like, for example, y equals to, I don't know, let's say x divided by 3. What does that mean? It's x over 3 bracket square, which is x square over 3 square, which is 9. Then the graph will just become flatter. Ooh, like this. Okay, not very nice. Should be symmetrical. In this case, actually, you will still say that you scale by a scale. You can think of this as equals to f of 1/3 times x. So this is a times x. Okay, wait, hold on. I'm gonna change the letter. I don't want to use a. I want to use b. Bx, where then the description is still the same. You scale by a scale factor of b. Oops. Is that okay?
Mm-hmm.
Can That's so multiplication and division, same thing lah. Here divide by 3. Dividing by 3 is equivalent to multiplying by 1/3. So division and multiplication is really the same thing. That's when you multiply inside the brackets. Okay. How about if you multiply or divide inside the bracket? How about if you have multiplication or division outside of the brackets, or directly or in other words directly towards the f? So for example, I want you to sketch y equals to 7 times of fx, which is 7 times of x squared.
Sure.
How to sketch? You just make it steeper. Okay. Okay, let me just double check something. Did I say anything wrongly? Yeah. +1 move left, minus you move right. That's inside. This is inside brackets.
Mm-hmm.
This guy +1 and -1. This one is outside brackets.
Mm-hmm.
Oops.
Yeah, okay.
Next one is inside the brackets, you multiply. Next one is outside the brackets, you multiply. So here, wait, what did I say? Still parallel to the y-axis. This is wrong. Sorry, I made a mistake in the previous one. Can I correct this? This is supposed to be parallel to the x-axis. Yeah, sorry. This is a bad example. X-axis. Still parallel to the x-axis. For the other guy, it will be parallel to the y-axis. You just describe it as the same thing. You scale parallel to the y-axis this time, but with a factor of 7. Can?
Okay.
Okay, yeah, basically all the y values times 7. So let's say I give you something like, you start with y equals e power x. Then I want you to sketch. Sorry, no. Let me start things off by sketching y equals e power x. It looks like this. Then I want you to sketch. Okay, let's call this fx. I want you to sketch y equals to f. Maybe I don't know. Let me think of something. 2 minus 3 times f of 2x. Okay, don't make it so difficult. Let's say just x minus 1. How does this look? Using the formula, let me introduce a formula to you. It's d plus c times f of bx plus a. Okay, so over here, what you see is that this fella is 2, this c is -3, this b is 1, this a is -1. Can you see the pattern?
Okay.
So what you
Yeah.
want to do is to follow the pattern from A towards B. A towards D, A, B, C, N.
Okay.
So let's start with A. We have a -1, right? This is what kind of translation?
It's like move left
Left
or
or right? Which one? -1.
Oh. This way.
Wrong. Minus move right. Plus then you move left inside the brackets.
Is this the one where you say like, oh, you
Opposite.
think of it like it's easier to is this not the one where you said like
it is? Yes. I think what you're saying is the story I said was here somebody nerfed you in a game. So what does the X have to do in order to fight
extra
back? You have to put in extra effort.
Okay.
Yeah, so that's
then
why
it's plus.
-1 you must +1. If
It's
enemy
plus.
nerf you, you need to work harder to get back to the same result. So it's left or right.
Okay. It's right.
Okay, let me just box this B and okay, draw this B and A. This is for horizontal. This affects the horizontal movement left or right, or scaling left and right. And C and D is affecting the vertical, to remind you. Okay, so what I like to do is fx, then arrow to fx -1, which is really just e power x -1. So how does the graph look? You simply move 1 unit to the
right.
So the graph will look something like this. Okay. Previously it was like 0, 1, so you'll move towards 1, 1. Okay, move 1 unit to the right. Does it make sense?
Mm-hmm.
Okay, good. Then next, after you do A, what do you do next? B. What does B do? B in this case is 1 times
Stay the
x,
same.
nothing happens. Then how about C? You times -3. So we draw an arrow. Oh, no space. Sorry, let me just draw an arrow like this. Y equals to -3 times f of x -1. This one, sorry, I didn't introduce just now. When you times negative, you have to reflect the graph about the, in this case, let me think, about the y-axis.
So it's like this.
Let me think, does it make sense? Sorry, about the x-axis. Yeah, my
Oh, so it's
Nice.
like this. Wait.
Yes, that's the correct one. Reflect about x-axis. Oh, there's another one. If it's y equals fx turn into y equals f of negative x, you have to reflect about the y-axis. So for example, y equals to x power 3. Sorry, maybe something more interesting. Let me write this above because it's not very relevant to the question right now. Let me add one more transformation. Where is it? Okay, hold on. Okay, let's discuss this first before we continue. So let's say we have a y equals, I don't know, what's a good example? X plus 1 power 3. How does that look? Y equals to x cubed looks like this. But when you plus 1, you have to shift it 1 unit to the left. So it's over here, negative 1, 0. Okay, then now what we're gonna do is call this fx. And now I want to ask you to sketch y equals to f of negative x. So what's f negative x? It just means you get negative x plus 1 power 3. Okay.
Okay.
How does the graph look?
Okay, so right, plus 1. So you can chill a bit. So wait.
No. Maybe I should just discuss this. Original was already fx. Original was already fx. Oh, sorry. Original was fx. So now I'm just asking for f of negative x. What's the rule here?
Reflect about y-axis.
Yes. So you don't need to. Yes. About the y-axis. No. That's about the x-axis. What you just drew. Y-axis is this one.
So like this. Like wait. That's what I just drew.
Yeah. The intersection will stay the same.
So like this.
Yes, correct, like this. Okay. So it will look like it will be symmetrical about the y-axis. Like this. Positive 1, 0. Okay. The purple one. Is it clear? The purple part. Okay, yeah, reflect about y-axis. Okay, back to the question. So what was I saying? Let's go to negative 3 times f of x minus 1. So you just reflect about the x-axis and you scale it up by 3 units. But here, when you make it times 3, what you're essentially doing is making it steeper. So for example, it will be something like this. Okay, it will be a bit lower. Okay, how? Bring the y-axis down. Then it will pass through 1, 1 again. Okay, what I'm about to draw is 3 times of this fx minus 1. This is what I just drew was 3 times of fx minus 1. Okay. It will pass through 1, 1. It will pass through 1, 1. Is it correct? No, that's not correct. Sorry. No. You times 3, yeah. You times 3 should be 1, 3. Where is my 1, 3? It's somewhere slightly above. Let me think. If I times 3, every y value multiplied with 3. Sorry, the graph should look like this. Just goes above. It's steeper. But it doesn't really matter when you're sketching a curve because making it steeper, you can't really tell apart from the original graph, as long as you are not drawing them on the same x and y axis. So what I'm saying is, forget the 3, just reflect it about the x-axis. Okay, so what you end up with will be something like this. Is that okay?
Okay.
There's still an asymptote y equals 0. Then after you reflect, you still got the next transformation, y equals to 2 minus away 3fx minus 1. So what happens when you have that plus 2? It's a d. D means
Move up
how many units?
by 2 units.
Here currently you have a horizontal asymptote y equals 0. So if you move up 2 units, what do you get? For your
You
new
have,
horizontal asymptote.
y equals 3 as your new. Wait,
Huh?
y
Y equals
equals
what?
2 as
Okay.
your as your new horizontal asymptote.
Yes, correct. And then you end up with something like, in this case, it passes through a certain point. Let's calculate this now. When x equal to 0, what do you get? You get, let's see, x equal to 0, y equals to negative 3 times f of 0 minus 1, which is negative 3 times f of negative 1. What is my f? My f is here. Fx is e power x. So f of negative 1 will be e power negative 1. Okay, so it's negative 3 over e. Then if I move up by 3 units, it means I will pass through this point here, 0 comma negative 3 over e, but I plus 2. Okay, if I move up by 2 units. So the graph will look something like
Positive 1.
this.
Wait.
Plus 2. Does it make sense?
Okay.
Can I? Yeah. Okay, good. Graphical transformations crash course complete. Next, continue. Wow, covering so many topics at one shot. Okay, this one, how? We now have x squared plus 1. How do you draw the graph? Let's draw a quick sketch on the green color part. If you recall this question, x squared plus 1 means you start with x squared, then transformation. This is if fx equals, I don't use f, I use g. If gx equals to x squared, then what is x squared plus 1? It just means g of x plus 1. So you move the graph upwards by 1, vertical translation. So it goes like this. Y-axis is here, x-axis is here, 1 unit there. Move up by 1. Okay, good. So let's think about it. At the x equals to negative 1, the boundary point now. You see these two are intersecting at the boundary negative 1 now. When x equals to negative 1, what is my x squared plus 1? Ayo. X equals to negative 1, x
Equal to
squared plus 1.
negative 1, 2.
2. Okay, so what's this? It's the same value as this guy here. Let me draw the green graph using blue color. So that means I'll have an empty circle here when x equals negative 1 because x is undefined at negative 1 here for the x squared plus 1 graph. But it happens to be the exact same point, right? It should be the exact same point. It's like I'm taking an empty circle and then I draw a happy face. And then I try to make it overlap. Okay, I bring the empty circle over. So I get an empty circle here. And then I draw the happy face. Oops, shouldn't curve. Okay, like this. And that's it. That's the sketch of the curve. Is that okay?
Okay.
Okay. So what else did the question ask? Let me double check. The verb. Yeah, I'll just draw the graph. Okay. Okay, good. Next question, let's go. What's the simplify function notation? You got fx equals to x squared plus 2x minus 3. Okay, then you want to simplify the following expression, fx plus h minus f of x all over a h. So how do you do that? When you see the x, and x, please remember there's invisible pairs of brackets like this. When you change it into a x plus h, just sub in, replace everywhere you see that had the x with all
X plus h.
Exactly. Okay, good.
X plus
So we just
h
replace with x
plus 2x plus h.
Yeah, that's for the fx plus h, but then you still have a minus fx. So minus sign, invisible pair of brackets. Always remember invisible pair of brackets after a minus sign. So invisible pair of brackets, red color one. What's fx? Copy and paste. Boom, this. Done. All divide by h. Can?
Okay.
Simplify this. A plus b bracket square. You know how to do this. You did so many rounds of binomial expansion. Right? 2hx and plus h square. Can? Okay, good. Then next one is plus 2 distribute 2x plus 2h. Minus 3 leave alone. Minus distribute, get minus x square minus 2x plus 3. Is that okay? Change the sign. All divided by h. Before you continue, simplify the numerator. Do you see any common terms? I see x square. I see minus x square. What happens? Cancel away. I see plus 2hx minus 2x plus 2x. These two cancel. Good. I see constant h square minus 3 plus 3. These two also cancel. What am I left with on the numerator?
2hx plus h square plus 2h over h.
All divided by h. Okay, maybe I shouldn't highlight the ones that are cancelled. Yeah, so it's clearer. Okay, good. Then numerator, do you notice that there's a common factor?
Yeah.
What is it?
H.
Right? Get 2x plus h plus 2. Okay, all divided by h. Anything to cancel now?
No. I mean h.
Yes, the h can cancel away. Then you're left with 2x plus h plus 2. Actually, I went through this before with you. Do you realize that if you... Okay, what this really means over here is that pretend that the fx graph looks something like this. Pretend that this is y equal f of x. What is this guy? X plus h minus fx, then divided by h. H, you can actually rewrite it as x plus h minus x, right? Does this look familiar to you? Something minus something divided by something minus something. Where have you seen this format before? Does it ring a bell? Gradient formula, right? It's a gradient formula. So what? So that means that you have a x1 at the bottom left, x2 at the bottom right, y1 at the top left, y2 at the top right. It's just that, it is the case, it's just that the y1 appears in a very funny format. This fella here is y1. This fella here is y2. That fella there is x1. That fella there is x2. What does it mean in terms of picture? What it means is this. If pretend that the fx graph looks like this curve, then you have a point here that's x, and then you travel a certain plus h distance. Then you end up at x plus h. What's your corresponding y coordinate? If this is f of x. When you have x is x, then just sub in, you get f of x. Does that make sense? Okay, then if it's the x is now x plus h, then what's your corresponding y coordinate?
Fx plus h.
Very good. So that means good with bracket like this. So that means that now you have a point here, x comma f of x. The next point here is x comma f of x plus h comma f of x plus h. So what we are really doing is this is like your x. Oh wow, the font size is very bad. Let me try and write it nicely. x1 y1 x2 y2. Oh sorry, other way around. Okay, fine. 1 1 2 2. Then you're trying to find essentially the gradient of what's known as the secant line. This fella here is m, which is the gradient of secant line. So now question. What happens if I let h go towards 0? What happens if I fix the x? Fix it. Don't let it move, but the h goes towards 0.
Smaller. Approaching fx. I don't know.
It's the picture. I think I've shown you this picture before. Maybe I draw it a bit nicer. Let's say it looks something like this. There's my x comma fx, and there's my x plus h comma f of x plus h. Then if I draw a secant line like this, sorry, I changed to red ink. Maybe use back a blue. If I fix my x comma fx, then I let the h get smaller and smaller. Essentially, it means that I am drawing a new line like this with a smaller h. You see the h here versus the h there. This is the new h. This is the old h. It's getting smaller. Then I can, if I keep on reducing it and making it so smaller and smaller, smaller and smaller, it becomes 0. Eventually, it becomes what? It becomes the
1.
secant line becomes what shape?
No. Wait.
The secant turns into a
y equals 0.
not just y equals 0. The x also goes to 0. Do you see? No, what I'm trying to draw here is that is a bunch of what's known as secant lines, but they all intersect at the same point. But eventually it will become what? Eventually when h equals 0, it will become this line here, right? These 2 points here and here, this point here will move towards the fixed point until the 2 points eventually are almost exactly the same position. Then in that case, there will only be 1 point, essentially, right?
Okay.
So this will be a line that passes through 2 points, but the 2 points are so close to each other, it looks like 1 point. What do you call a straight line that touches a curve at only 1 point?
A straight line of a curve that
touches only 1 point of the curve. Straight line that touches only one. Tangent line, very good. Exactly, that's exactly what I'm trying to lead up to. Sorry, my drawing not so good. So the secant line will turn into a tangent line. So that means that when we try to find what we have just found here, 2x plus h plus 2, right, is essentially the generic form of the gradient of a secant line, a very special secant line where it contains a fixed point and a moving point. The moving point is moving towards the fixed point. If h goes towards 0, or what we call the limit as h goes towards 0. Does that make sense? And as you move this fixed point towards move the moving point towards the fixed point, your secant becomes, the picture version is the secant becoming a tangent. But what we just found is the m of the secant, the gradient of the secant. So eventually, if you let h goes towards 0, you'll get the m of the tangent. Gradient of a tangent. Is there a certain formula we know to find the gradient of a tangent?
Differentiate.
dy by dx, right? Oh. So that means that if I take this value here, if I take the limit as h goes towards 0, what that means is you let h go at smaller and smaller, but eventually if h goes towards 0, it's just equal to 0. So what is this equal to? It's just 2x plus 2, right? Isn't that just the derivative of f? F prime x is 2x plus 2. It's the same. Differentiate, you get 2x plus 2. You find this super long-winded formula, gradient of a secant line, blah, 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 cancel off the h, cancel off the h. You get this expression. You take limit as h goes to 0. You also get 2x plus 2. Wow. What a coincidence.
It's not a coincidence.
It's not a coincidence. This is known as the limit definition of a derivative. Okay, you're getting closer to figuring out the reason why you need to memorize the rule, bring down the O power minus 1 to get the. It's because of whatever you just did. Okay, what essentially happens is that when you expand a bracket plus h square, you get x squared plus 2hx plus h squared. Okay, but because there's a minus x squared here, they will cancel off. Then you're just left with the purple color 2hx, which is the which essentially means that the power dropped by 1. You see, this is power 1. That's a 2 there. Bring down the old power 2 minus 1 to get the new. You brought down the 2 and you subtract 1 to get a new power. Okay, but don't worry about this. That's for university. Calculus 1. You'll learn more about this. Just wanted to give you a, but they expected you to know how to simplify this. Okay, this part here you need to know. The logic here about secant turning into tangent line, you'll go figure it out in university. Engineering math. Okay, next, let's try a domain function. Domain question, what is this? Find the domain of the following question, blah, 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 expression. Domain equals question mark. So what is domain? First thing you must understand is something known as the natural domain of functions. So there are certain operations that are never allowed in math, such as dividing by 0. You cannot do that. What else? Taking logarithm of a negative number, that's not allowed, right? Square root a negative number, that's not allowed. You introduce complex numbers. So that gives rise to natural domains of certain functions. So for example, y equals to 1 over x. X can never be equals to 1 divided by x, never divide by hello? Wait.
Never divided by 0.
0. So x is not equal to, the symbol here is not equal to 0.
0.
So the domain will always exclude 0. So this in terms of set notation will be set of all x an element of real numbers such that x is less than 0 or x is more than 0. Curly brace. This is the domain, the natural domain. Naturally, you have this because you cannot divide by 0. That's example 1. Let's here's our next example. What if we take y equals to ln of x? What's the natural domain? Can x be negative?
X cannot be negative.
How about 0? Can it be 0? Can you take ln of 0? Type in a calculator and you quickly check. What do you get? Ln of 0?
And
ln 0 equal, what do you get?
I get undefined.
You get math error. So that means that you can't just, not only negative is not allowed, 0 also not allowed. Therefore, x must always be more than 0. Naturally, you have this domain, x must be more than 0. Next one, we have y equals square root of x. Can you square root negative numbers? Cannot.
Cannot.
Can you square root 0?
Wait, don't yeah. Okay, wait, can you?
Just type in a calculator.
Yeah.
Yes, so therefore it's more than or equals to 0. These are the natural domains of these functions. Okay? Okay. With that, you can solve this question already. Let's take a look. Let's first look at the fraction. You have divide by x minus 1. Never divide by, I already drew it there. Never divide by.
You cannot divide by 0.
Therefore, you'll say x minus 1,
X.
you purposely make it not equal to 0.
Okay.
Which means x equals to, not equals to, sorry.
X not equal to 1.
Very good. So that's a band value. Okay, so by default, you can assume that x will take on all real values. But then you slowly find out that, wow, x cannot be equal to 1. Then you drop it, you eliminate, you put him in the blacklist. At first, everybody can go this Mickey Mouse clubhouse. But then somebody realized that, 1 very bad. I don't want 1. If not, it will cause trouble. So you put him inside the blacklist. So the bouncer will be outside. Don't allow you to enter. No, 1 cannot enter. That's how you define a domain. You start with a set of all real numbers, and then you slowly chop off the ones that are not allowed, using the idea of natural domain. There's more, actually. These are only 3 examples. Other examples include, like say, y equals to tangent of x. x cannot be negative pi over 2, x cannot be pi over 2. I think we discussed this just now, right? Vertical asymptotes. So there's a natural domain, which is the principal domain, which is negative pi over 2 less than x less than pi over 2. Oh. Yeah, so, there's many other examples, but I guess these 4 should be good enough. Yeah, these 4 should be quite plenty to actually the first one and the third one is enough to solve this question. So let's see. Okay, good. We managed to figure out the first band value, x not equals to 1. Let's go on to figure out the others. So numerator, what do you see?
4 minus, I mean, square root 4 minus x squared. I mean, okay, it cannot be a negative number, so it cannot. The inside cannot be a negative number, so 4 minus x squared not equal to 0.
Okay, and maybe it's easier if we think of it as more than or equals to 0.
Oh yeah, okay.
So from there, you have to solve a quadratic inequality. You know how to solve, right? Okay, here's a suggestion. What if we do this? X squared less than or equal to 4, I take square root on both sides and I get x less than or equals to answer. Correct?
No. Wait, no. Cause
you're losing an answer. Yes, correct. You need to draw a curve. So what you're supposed to do is x squared less than or equal to 4, bring the 4 over, you get minus 4 less than or equals 0. So this is x squared minus 2 squared less than or equals 0. Factorize, you get x minus 2 times x plus 2 less than or equals 0.
Minus
Happy
2
face.
and then 2. So less than 0. So it's this in between here.
Okay, so I'll call this condition 1. I'll call this condition 2. In order to have a domain, you're supposed to satisfy condition 1 and condition 2 at the same time. Okay, so let's draw a number line to represent this condition 1 and 2. Condition 1 is, let me just copy it so I can have it on the same screen. So here's 1. The first condition is saying all values of x except for 1. So it's really just this picture here. Okay. All values of x, but not 1. The next condition 2 is saying negative 2 less than equal x less than equal 2. So here's negative 2. Here is positive 2. Okay, not very balanced. Negative 2 here and 2 is a bit closer. Okay, then you want less than equal. So it's this direction, shade in, this direction, this value, shade in, and that direction there, right? Wrong. What am I saying? No, this way. So where's the overlap?
The overlap is over. Oh my god, is here. Wait. Right.
And
when x is more. Wait. When x is more.
Wait, wrong. We haven't finished shading all the regions. There is one overlap. Then after that, there's a empty space here, like a positive 1. But there's another region here.
Yeah.
Right. Black solid line with black solid line. This part overlap. Black solid line with black solid line. This part overlap. So now we must translate into math notation. First half here. Negative 2 less than x. Oh wait. Less than 1. Where do you put an equal sign? Black circle.
Oh, you put here.
For 1
No.
Because empty circle. This person say I don't want positive 1. This person says I can accept positive 1. To satisfy both conditions at the same time, you always accommodate to the strictest person, which is the person who doesn't want 1. So you don't put a equal here. And the other guy is 0 less than 1 less than x less than 2 inclusive of 2. I like to go from small to big. 1 then 2. Okay, then is it N or R?
Oh my gosh. Okay, if it is 2
two separate regions. Can you be both places at the same time?
No, it's or. It's or.
Yes. Okay, so how do you define it in a set notation? You'll say domain equals to a set of x values such that at first I will say it's in the set of all real numbers. However, the x must obey certain rules such that the x follows these rules we just discovered. All the real numbers in this interval. Oh, by the way, let's say extension, just a bonus on set notation. What if I tell you this guy, but I change the R there to N? This is the set of 1, 2, 3, 4 all the way. What would this set be equal to? What's inside the set? How do you read this? It means that you look at x values which are in the set of natural numbers, which are 1, 2, 3, 4, 5 all the way to whatever infinity. And those x values, you only look at those that satisfy these two rules. In other words, you're looking at this interval and finding out all the positive integers. What would those be? I see a -2 is inside this set. I see, let's look at integers first. I see -1. I see 0. I see 1, but 1 is excluded, so I exclude it. I see 2. Okay, that's it. So that's natural number. Sorry, that's integers. Okay.
Okay.
Right. But that's not natural numbers, right? Natural numbers start from 1, 2, 3, 4. So which number satisfies the rule? It has to be 1, 2, 3.
2.
2. So that means this set is just 2. Do you see the difference?
Okay.
So the moment you change the what's known as the universal set, the set changes entirely. Okay, this set has many values. It could be -2, it could be -1.9999, it could be negative 1.98, it could be all the values in between. It could be less than 1, is it? So it could be I don't know, 0.9, 0.99, but never equal to 1. And you skip many values, and then you go 1.1, 1.5, 1.9, can be 2. And everything in between can have a lot of values. But here, it's only just a single number, 2. Do you see the difference?
Mm-hmm.
This is set notation. Yeah, universal set, and then the rule. This is the, what do you call this? I forgot the name, but this part here is called the rule. This part here is the universe, I guess, the type of numbers that the set contains. It contains natural numbers, or it contains real numbers. In the future, you'll see X an element of C, X an element of complex numbers, A plus BI, but don't worry about it. Complex. Okay, so it matters in set notation. Yeah, so that's how you describe domains. Let's see, what other questions should I discuss? Let me see. Domain. Oh, right, interval notation. Yes. So this notation, if you find it difficult to understand, there is alternative notation. It's known as the interval notation. Interval notation. It's this set is exactly equal to the following: -2, 1, round bracket, union with open round bracket, 1, 2, close the square bracket. What does it mean? Here you see equal sign, then you put square bracket. Here you see strictly less than, doesn't include 1, you put round bracket. Here you see strictly less than. So you don't include 1, you put round bracket. Here you see an equal sign, you put square bracket. You must always write from small to big, so that in the interval notation. So previously you wrote down the inequality 2 more than equal x more than 1. Yes, that's true in the inequality notation, and you can use this if you're using the set notation, but it will not be advisable because it doesn't pair well with the interval notation. This guy is called the set notation version. Above one is called the interval notation. Okay. Can yeah, so learn to write the inequality from small to big so that you have an easier time translating between the two. Okay, so for interval notation, small, comma, big, and then round bracket or square bracket, depending on whether you include or don't include the number. Equal sign you include, put a square. No equal sign means exclude the number 1 in this case, then you put a round. Maybe I should put this. Equal in inequality, then it's a square bracket. And no equal, then you put a round bracket instead. Is that okay? No equal, round bracket. Is that okay? Interval notation.
Okay.
Good. Okay, let's try another one. Question, inverse. Find the inverse of the following function. Y equals to 3 over x plus 5. So to find the inverse, here is something that is actually sometimes taught in O-level Emacs in certain other international syllables. Here's how you do it. Step 1, make x the subject. Step 2, swap x and y. Let me show you with a different example.
I feel like you've told me this.
Have I told you this? Or maybe I did. Maybe I did. Let's try an example. Let's say we have y equals to I did it for tangent inverse, maybe sine inverse. Let's try an example. Say we have x, don't square, x cubed over x minus 2. Oh, that might be a bit too difficult. Sorry. Let me make it a bit simpler. Just x cubed plus 1 over y. Okay. How would you solve this?
Okay. Wait, you want to find, where will you find?
Maybe don't put y, just make it simpler. Let's just put a number. Okay, so I want to find the inverse function.
Okay. And
Exactly, that's it.
then y equals to 8x minus 1. What the?
Okay, okay, let me show you the graph of this guy and that guy. Okay, y equals to x cubed plus 1 over 8, and y equals to bracket 8x minus 1 power 1/3.
They reflect about y equal x. Wait, I mean y equal x.
About y equal to x, exactly. Yes, correct. Let me share this. Let me share the decimal screen. Can you see? So let's draw the graph. FRAC for fraction, x power caret 3 plus 1 over 8. And then you draw the other guy, which is bracket 8x minus 1 whole thing to the power of 1/3, which is the same as cube root. You see? It's a reflection about y equal to x. The graph will always be nicer than the hand-drawn one. Okay. Does it make sense? Like an octopus?
Yeah.
Okay. I don't know. Some weird octopus. Okay. So anyways, it's reflected. And a few things to take note is that there's always these 2 points. Sorry, not 2 points. At least one of these points, which is the point of intersection between y equal to x, y goes to fx, and y goes f inverse of x. this point here. Do you notice that they all pass through the same point?
Yeah.
The purple, the green, and the black, they all pass through the same point. This is a very common point. It will always happen. It will always happen. It can be proven, but don't need to prove it. Just need to know it. Fx, f inverse x, and y equal to x, they will always pass through the same point. And you can find that the coordinates of that point. You can find it. You just have to equate to x and solve for x. Equate two of the lines, the graphs, and then you solve for x. Solve for okay. Can I? Okay, go back. So now time for you to try on the actual question. This one, y equals 3 over x plus 5. Good. Step 1 is complete. Good. Yeah, that's it. Okay. Done. Okay, so they will be, that's the inverse function. Yeah. Sorry, did you say something?
No.
No. Okay. Can. Then if you want to make into a same fraction, you can treat this as 5 over 1, then times x and x at the top and the bottom. So you get 3 minus 5x over x. Oh, okay. Okay. Can. One more topic. Let's look at this one. Draw a graph of, okay. Here, okay. What is this? X squared plus x, all divided by x squared minus 2x minus 3. Okay. So how do you draw this graph? How do you draw this graph? First thing you must see is what is the
partial fraction. Wait,
no,
no. Improper fraction.
Yes, correct. Degree of the numerator equals to 2. Degree of the denominator equals to 2. You need the degree of the numerator to be strictly less than degree of denominator. Then this is the definition of a proper fraction. Here it's not 3 less than, it's equal, so you have to do long division.
Okay, wait, then okay.
Yeah, then that's it. So therefore you get 1 as the answer.
1
minus 3x minus 3 as your quotient divided by the x squared plus x. Okay. Just write it down. X squared plus x divided by the x squared minus. Hey, hold on a second. Wait a minute. Did you swap the order?
I did.
Okay. No. Redo. Okay, let's just do it together. So x squared minus 2x minus 3. So let's take a look. So x squared, take the leading term, divide by x squared, the leading term, x squared over x squared gives you plus 1. I like to write it at this separate column. You don't need to. Then times in, so you get x squared minus 2x minus 3 because positive 1 times that thing. Put a pair of brackets. Put a minus outside. Draw a line. X squared minus x squared, what do you get? Nothing. Plus x minus 2x. That's a x plus 2. 2x, which gives you a plus 3x. Minus 3 become plus 3. Okay, good. Now x power 1, the degree is less than power 2, so you stop. This guy is your quotient. This guy is your remainder. So what do? You write down quotient 1 plus the remainder, 3x plus 3, all divided by the divisor. Okay, this guy over there. Whatever was on the denominator remains on the denominator. Okay, denominator here, denominator there. Can? Is that okay? Can now? Mic test. Can you hear me?
Yeah.
Oh, okay. Good. So now what you need to understand is that this part here, the quotient is the asymptote. It will either be horizontal or oblique. So you'll just take y equals to the quotient. Quotient is the answer. Quotient. Okay. So in this case, it's a y equals to 1. So it's a horizontal asymptote. So what you do is you draw the y-axis, you draw the x-axis, you draw a y equals to 1. Y equals to 1. Okay. What else? Then now you have this guy here. Never divide by, never divide by.
Never divide by that.
Huh?
Uh-huh. Yeah,
Never divide by
mean?
natural
What you
domain.
mean?
Natural domain.
Oh,
You can
never
cannot
divide by 0.
So you force the denominator here equals to
0.
0. Yes. Or okay, I'll put the not equal. You can put the not equal to, or you don't put. Doesn't really matter. Just know at the end of the day, it will be not equals to. So from there you solve. This is actually just minus 3 plus 1. Right? Good. So x equals to positive 3 or x equals negative 1. So these are the band values. Not equal, not equal, not equal, not equal.
Okay.
So we end up with positive 3 here and negative 1 there. So negative 1 here, positive 3 there. These are what we call the vertical asymptotes. Vertical asymptotes, because it's literally vertical. Okay, good. So asymptotes means that when the x value, usually when the x value is close to those, sorry, when the graph is close to those, sorry, how should I phrase it? For the vertical asymptotes, you will approach the vertical asymptote but never touch it. The graph will approach the asymptote but never touch it. But for horizontal and oblique asymptotes, for small values of x, you may still intersect with the graph for certain examples, but only when x is very big or x is very small, then you will approach the horizontal or oblique asymptote. Okay, so let's just figure out how to draw this graph now. Strategy, plot a point. In each of the separate regions. How many separate regions do you see? By separate regions, I mean separated by x, by the domain.
3.
Yes, here, here, and here, correct? Please don't go and look horizontally like here and here, then 2 regions. No. We look at the domain. So those that are less than -1, in between -1 to 3, and more than 3. Strategy. At each of the regions, you plot a point. Each. So there will be 3 points altogether. So let's pick a point like, say, x equals -2, x equals to, let's say, 0, because 0 is in between -1 to 3, and something bigger than 3, let's say x equals to 4. Find the y. Just sub in. Can you help me?
Yes.
Yeah, so I'll do x equals to 4. Can you help me with the others? Careful.
Yeah.
Huh, sorry?
I get wait, syntax error. I get -3/5.
Okay. I got 2/5. Okay.
Wait. Let me try that. Wait.
The brackets before you square, -2 square.
Yeah, I did that.
Did I type
Minus
wrong?
2 times. Oh, I forgot +1.
Ah, that's a +1, yes. Oh, right. -3/5 +1. Yeah, 2/5. Okay. 2/5. Okay, good. Then now we can plot points. Plot those points. -2, comma, positive number, so it's somewhere here. 0, comma, 0, so somewhere here. 4, comma, 4, so somewhere here. Right?
Okay.
Okay, good. So now, in order for your graph to pass through those points, it will always have to approach the vertical asymptotes. So near the x equal -1, you can only have two options, either curve this way or curve that way. If you want to, and horizontal asymptote, you cannot cut across it, right? Usually. So if you already have a point that's above the y equals to 2 horizontal asymptote, sorry, y equal to 1 horizontal asymptote, do you think it could be still this part of the graph? Is there a way?
No, it will be like this.
Not really, so yes, it should be the
Wait,
top.
but it's 2/5.
Sorry, let me see. Oh,
And then
sorry.
y equal 1.
Oh,
So it'll be this.
my mistake. Sorry. Yes, you're correct. Made a mistake. Whoops. Yes, 2/5 is below y equal 1, so it should be below. So it should be this part. Okay, good. Then for the next half, if you want to approach the two piece, it's either this way or that way. Which one? Yes, correct. And then you can also differentiate equal to 0, solve for x to find the turning points to be more precise. Okay, so because it could also be this curve, like this. Like the turning point is to the left. Or it could be the turning point is at the origin itself. Or it could be somewhere a bit more to the right. I don't know. Haven't checked yet.
When you say turning point, right?
Turning.
You mean
Turns.
like delta? Wait, why like?
Yes, correct. That's the differentiate equal to 0, solve for x in this equation.
Okay.
Yes, that's the differentiate equal to 0, solve for x. Table to determine maximum or minimum, but confirm must be maximum by just drawing the curve. Okay, then finally the last one must be this one. Okay, you only have two options, the bottom or the top. Okay, approaching the asymptotes, it must be a top one because we pass through a point which is 4,4. 4 is above 1. Okay, that's the graphing of rational functions. Yeah, long division, you don't use partial fractions here. Let's see, other questions. Divide x cubed minus 9 over x squared plus 2x minus 1 and find the oblique asymptotes. Oblique asymptote will just simply be the quotient. Okay. It will be the quotient.
Wait. Quotient is the one on the
Answer, up there. Sorry, I shouldn't use technical words. Here's the answer. Then the leftover, remainder. The answer here will be written here. You plus the remainder divide by the.
So I just do long div.
Yes, just long division. X cubed minus 9 divided by x squared plus 2x minus 1. That question. Let me write this down. Then you want to find oblique asymptotes. Oblique just means slanted. Okay. Oblique. So yeah, if you do long division, let's just do it quickly. X cubed minus 9
times x.
minus 9 should bring over to the right side like this. Then
minus 2x plus x.
oh no, minus 2. Is that okay?
Uh-huh.
Cannot. Yeah, then therefore you get the answer is x minus 2 plus a remainder 5x minus 11 all divided by x squared plus 2x minus 1. This guy is your oblique asymptote, y equals to x minus 2. Okay, then for vertical asymptotes, never divide by 0. So you force the denominator equals to 0. Preemptively find the problem. Okay, equals 0 and then blah 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 solve for x. You get the same as. Actually, no, it's a different question. Sorry. Really need to calculate. Let's see. This is wait a minute. 1, 2, -1. Not so simple. So I think the answer is, I'll just round off to 3SF from the calculator. -2.41. Okay, these are two vertical asymptotes. Okay, so let me just draw the graph for you on the decimals and convince you. So what we have originally is x cubed minus 9. Is it clear? Is it showing?
Mm.
Can you see? Okay, good. Then the denominator is x squared plus 2x minus 1. Okay, it looks like this. The scale doesn't look so nice. Let me just change it. Oh, 20. Yeah, that's the best I can do. Okay. So what you see is that there is a y equals to, this is equivalent to what we just found, x minus 2 plus the 5x minus 11 over x squared plus 2x minus 1. You see the blue and the red overlap exactly.
The same.
Y equals x minus 2. What do you see? Oh, it's a green line, which is the
asymptote.
Asymptote. Yeah, it's getting closer and closer towards it, but never exactly touching. Okay. Does that make sense? I hope it makes sense. Yeah. Hold on, something is
It passes through.
It passes through. Oh, yeah, that's why I found it a bit odd. Let me think. Does that make sense? Unless there was a calculation error. Sorry, I'm checking the working. Okay, it's correct. Yeah, correct. For small values of x, graph can pass through an asymptote. Small values of x, 2.2. Only for large values of x, then asymptote means that it's approaching closer and closer towards it, but never exactly equal. Yeah, yes, correct. Can pass through. Okay, good. How about vertical asymptotes? The two roots we found, 0.414. Okay, it's not exact, so it won't be 0. It won't be exactly the asymptote. If you want the exact asymptote, you have to use quadratic formula. X equals -b plus minus square root b squared minus 4ac over 2a. 4ac over 2a. I think it's quite convincing. Okay lah. Something like that. So you get the two vertical asymptotes. Anything else I need to cover? Let's see. The rest you should be able to solve. Oh wait, no, one more. Inequality. Okay, let's go through that. Last question for the day. Okay, I didn't go through the homework, but okay. It's all right. Maybe arguably this is more important because this is sent by your school, is it?
Yeah,
it's probably more important. The next one is interesting graphic design. Not sure, but okay. X times x plus 5 square times x minus 3 less than 0. How do we deal with this? So what you're supposed to do is something known as the sign test. So this is a more general way instead of drawing quadratic curve. So previously, if we have like, for example, x minus 7 times x plus 2 less than 0, what I ask you to do is to draw quadratic curve. You get -2, +7. Then less than 0, this part below, right? Then you conclude -2 less than x less than 7. There is something known as a sign test instead, which you can do. So what you do is you draw a horizontal line. You equate each of the factors equal to 0. First guy equals 0, something equals 0. Solve for x, you get 7, -2. Then what you do is you substitute values in this, and this region. Can you see that you essentially, because of the x equal -2, x equals 7, you split into 3 separate regions?
Yeah.
Yeah, you pick a value of x that's in each of these 3 regions, sub in to the expression, and then you check the sign, plus or minus sign. Okay, so let's do that. So let's pick maybe x equal -3. Let's say pick x equals 0, pick x equal to 8. Then we sub in to see the value. Sub in to see the sign of the expression. So in this case, we become -3 minus 7 times -3 plus 2. This is -10. This is -3 plus 2, -1. So negative times negative becomes +10. So we put a plus sign here. And if you do the same for the rest, you get negative and positive. How do I know that? Because I see the graph. Above, below, above. That's a hack, huh? Of course, what you do when the official way to do it for sign test is really sub it. Really legit, you need to sub it. Okay, then you let's just do it for demonstration. 0 times -7, 0 plus 2.
-14.
-14. The sign is more important, the 14 not so important. Then 8 minus 7 times 8 plus 2, you get +1 times 10. Oops, 10, which is +10. So positive. Okay. Yeah, then from there, you want to figure out which part is less than 0, right? Clearly, negative part is here, right? So -2 to 7. Does it make sense? Yeah, that's it. So now, how about this part? You do sign test as well. Each factor equal to 0. So there's a factor here. There's 2 factors here, but they are both x plus 5. There's a third one. So essentially only 3 factors, so 3 roots. What are the roots? This one, the first one will give us x equal to 0. The second one gives us x equal to -5. Third one gives us x equals to +3. So can you just put 0, -5, and 3 here? Just follow. Can or not? Number line. -5 in the middle, 0 on the left side. Can oh no.
Wait.
Number line negative on the left, 0 in the middle, positive on the right.
Oh, cannot.
Sorry. Clearly cannot. I was trying to trick you. -5 on the left. Is it clear?
Oh.
I hope you remember. I always try to trick you. 7, -2. Write it in the wrong side. Negative on the left. Smaller on the left, bigger on the right. Okay. -5, then 0, then 3. Okay.
Okay.
Can Then now you pick a point. Say x equals -6. X equals, what's a good number? -1. X equals bigger than 0, less than 3. 1. Bigger than 3. 4. Then find the corresponding y value. Let's just call this y equals. What's the y? Sorry. So maybe if you want to be smart, you can do the following. This is become -6. This one become -6 plus 5, which is -1 square. Then this is -6 minus 3, which is -9. So this guy become positive. This guy is negative. This guy is negative. Altogether, the sign becomes positive. Then all you need to do is put down a positive sign. Don't need to care what value it is. Plus. Okay. Next one, x equal -1. So y equals to -1 times -1 plus 5, which is +4 square. -1 minus 3 is -4. This part is negative. This part is positive. This part is negative. Altogether, you get Negative times positive times negative gives you
negative.
negative.
Hey, positive, negative,
Positive.
negative, positive, 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 positive.
Correct. Then the next one, x equal to 1. No space. So y equals to positive 1 times 1 plus 5, which is 6 square, times 1 minus 3, which is negative 2. 6 square is positive. 1 is positive. Negative 2 is negative.
Negative, negative, negative.
Negative. Put a minus here. And then x equal to 4. So y equals to 4 times 4 plus 5, 9 square, times 4 minus 3, positive 1.
Positive.
Positive. Okay, good. So when is it less than 0? Here, answer is 0 less than x less than 3. This is called the sign test. You can go Google if you need more practice questions. Okay. Good. One more thing that I saw that they need you to know is conic sections. Here they are asking you to draw this guy, which is a circle. So hold on. Wait. Nope. Let me double check. Yes, it's a circle. Yes, positive 1, positive 1. Now, there's other things known as ellipsis and hyperbola. It can get quite intense when they start talking about eccentricity, but I don't think you need to know that. What you need to know is the basics. So first thing is ellipsis will have a coefficient that is both the same sign, positive usually, but the magnitude is different. So plus 1x squared and maybe plus 2y squared equals to 1. Okay. In that case, because 2 and 1 is different, that's why you'll get an ellipsis. Here it's plus 1 and plus 1, same, then you'll get a circle. It sort of balance out the stretching on the horizontal and vertical. But here it's a 1 and a 2, the stretching amount on the horizontal and the vertical is different. You get an ellipsis, which is essentially just an oval shape, chicken egg. Like this. Or like this. Okay, maybe I'll talk more about it next lesson. Hyperbola is the other kind where the sign is different. So maybe positive x squared, then minus y squared equals to 1. Here, the sign is different. That's all. That's the key to getting a hyperbola. Sign is different. So positive x squared, here's what my teacher taught me many years ago. Positive x and draw x. The graph will be something like this. It will look something like this. Of course, it's not very accurate. More accurately, it should be there's a certain asymptote here. And then you draw the hyperbola. Like this. But if it's a plus y square instead, y square minus x square equal to 1, then this guy is a positive y square. Maybe I use a different color. Positive y square, then you have a y shape. Cursive y looks like this. Some people have a tail. And then at the top, at the bottom, that's your hyperbola shape. So it's x. Oops. Okay. Yeah. So how does the graph look? It will look something like this. Asymptote, top, bottom. You must approach the asymptote. Okay. Yeah. Okay. Good. That's how the graph will look. Good. Okay, that's it. That's all for today. Oh.
Okay.
Thank you. I'll talk more about ellipsis next time. For integration techniques, go and try the questions. You haven't tried yet, is it?
Okay.